Let's imagine that I pull from a bag a brown triangle, a red square, a green circle, and a brown rectangle. How many different ways could I put these in a line? Well, that's one way, right? What could I do next? Well, I could shift everything over and do square, circle, rectangle, triangle. And then I guess I could keep shifting and say circle, rectangle, triangle, square. Let's see, what else? I could have rectangle, triangle, square, circle. And then I could start putting them in different orders. Like, everybody's had a chance to go first. So, how about we mix up triangle, circle, square, rectangle. Ooh. And on and on. You can see that there's quite a few different choices. These are called permutations. Permutations are a mathematical way to talk about when something's in order. And the order in these matter. So I can't just grab into my bag and say, "Ooh, I've got a triangle, a square, a circle, and a rectangle." I've got to have them in some sort of order every time. Well, how do we figure out how many orders there are to choose them? Because this would take forever, right? So let's clear this off, and we'll talk about how to just know that numerically. Okay, to figure out how many permutations something has, you need to use a factorial. Factorial is represented with an exclamation point. And you'll see a number like 4, because I had 4 objects before, and then an exclamation point. And what that means is to take the number and then count down from that number till get to 1, multiplying everything. So 4 factorial is 4 times 3 is 12, times 2 is 24, times 1 is still 24. So there were 24 ways to arrange those 4 items. Pretty neat, isn't it? Now, what about if I draw 5 cards? How many different ways could I put them in my hands? Well, it's 5 factorial. So 5 times 4 times 3 times 2 times 1, which would be 24 times 5. So 20, 10, 120 different ways. When you have a factorial, it can go up rather quickly. Okay. So, anytime that you're talking about permutation, you'll need to use a factorial. Okay. Another thing to talk about in this chapter is called the counting principle. Okay. Have you ever gone into McDonald's or Chick-fil-A and looked at the Happy Meal choices, the kids' meal choices? There's probably about 3 different ways that you can have the main course. Maybe a hamburger and chicken nuggets and let's say cheeseburger. And then from there you could branch out and you could have either, let's say, fries or apples. And from there you can have milk or juice, Coke or Dr. Pepper, water, Sprite. So just using these choices, how many different ways could I have it? Well, I could have the hamburger with the apples with the Sprite. Or I could have the hamburger with the fries and the Dr. Pepper. Okay. So to figure this out mathematically, we'll use a counting principle. All we need to do is count how many choices we have in each group and then multiply all that together. So I have 3 choices here, 2 choices here, and 6 choices here. So I have 18 times 2 is 36. 36 different ways that I could make a meal. And that's called the counting principle. Now, again, what's the difference between using a permutation and a counting principle? Counting principles, when you have groups and you have to take one choice out of each group. Permutation is where you have a bunch of things and you're going to line them up in order. Right, let's go back to permutations now. Let's say I have my shapes again. Triangle, circle, square, rectangle. And instead of having all 4 shapes, what if I pull 2 out of the bag and lay them down? How many different ways could I have laid down those 2? Well, I could have triangle, circle, and circle, triangle, because those are different ways. I could have triangle, square, or square, triangle. I could have circle, square, square, circle. I could have circle, rectangle, and again on and on. So how do we figure out how to do this? Well, it's not going to be as many as a permutation. So we have a formula, and it's N, where N is the number of objects I have to start with. P stands for permutation, but I tend to say pick. And then R, it's like how many am I going to pick out of my N things? So I have 4 things, and I'm going to pick 2. So that's how I would write it on my paper. Now, the formula to get this is you take the number, so the 4, and you're going to do a factorial over, and then you're going to have the N again, the number, the 4, minus your R number, 2, and make that a factorial. So that's going to be 4 factorials, 4 times 3 times 2 times 1. 4 minus 2 is 2, and 2 factorial is 2 times 1. Now, there's something kind of fun with factorials in that you don't need to always do so much math with them because they're easy to cancel out. Do you see that I can cancel these 2's out because there's a 2 on the top and 2 on the bottom, and also the 1's. So all I have is 4 times 3. So I have 12 different ways I could draw out 2 objects. Pretty neat.